All right. So today we are going to be taking a look at explaining the evidence of climate change. Actually, this whole week. This whole week we're going to be looking at evidence for climate change and then taking a look at what are people's perspectives about climate change. So we are technically in week 2, or activity 2, of this project that we're going to be doing here. All right, so many of you have probably heard different things about climate change, and we're going to talk a lot about these different aspects. So you probably heard people have very polarizing statements, things like climate change is due to human activities versus climate change is due to human and natural causes. Or maybe even a third one on there, climate change is all natural. You guys have probably heard of things like that before, right? Where people kind of pick one and they kind of stick with it. Right? So what we're going to be doing here is that we are going to discuss this data and kind of pick what is your perspective on climate change. You probably also heard these type of statements before. Nearly all scientists agree on climate change, or not all scientists agree on climate change. Okay? No matter what, you're never going to get 100% of the population to agree on anything. Okay? That's just the reality of it. Okay, we're human. We're not perfect machines like that. Okay? So again, when you have these kind of statements, they tend to be very polarizing, one way or the other to the extreme. We do want to make sure that we focus on the idea of beliefs, assumptions, and then perspectives and data. You have to understand your own belief, assumption, and then your own perspective, and what is based on science, what is based on data, and what is based on what your friends say, what your parents say, etc. Not saying one or the other is right. You just need to have that understanding within yourself, though. You know, do I have evidence to back up my statements? Or am I just saying something that I believe, that I simply believe? Okay? And again, you need to know that within yourself as well. Okay? So when we talk about the word belief, and change that word a little bit to believe, okay? This is often ideas that people think are true. Whether or not they're true, people think that A, B, C are true, okay? They are based on their experiences, their faith, what somebody said, and they think that that statement is true. The important thing about beliefs, though, is that they can change as you get new experiences. And your beliefs can change as you get new experiences because your beliefs are based on experiences. So your belief with climate change, global warming, whatever, okay, what you think right now can change either way or in any possible way. It can change as you get new experiences. You, especially young children and young adults, you guys really should not have any concrete beliefs right now. Okay? You guys should be willing to learn and change and experience everything. Okay? And that's what you should do as young adults. Once you settle down, once you start having your own little kids and stuff like that, you probably do want to have some concrete beliefs, stuff that you're going to set your life based on. Okay? But you should always have new experiences. Take them in and think. You know? There's nothing wrong with that. Okay? Now, assumptions are underlying ideas that back up your beliefs on climate change and global warming. Okay? The idea behind it is that they take evidence that you heard or seen, and you connect it to your belief or your idea that you have to these assumptions. These assumptions may or may not be based on facts, though. You got a piece of evidence that may or may not be right, and you use that to back up your beliefs. That's a dangerous one there. If it's not, if it's not true, you're backing up your belief with something that's not true. That's that's a very dangerous one you want to watch out for. It is important for you to understand what is your assumptions, what are your underlying ideas, and what is your belief when it comes to climate change and global warming. Okay? So, some samples of belief here. Carbon dioxide, one of many atmospheric gases. It makes up a small percentage of gases in our atmosphere. Okay? So the belief is carbon dioxide is a gas. I think most people agree with that. And it is a small gas in our atmosphere. I think most people agree with that as well. Most of the gases are nitrogen or oxygen-based. Okay? So an assumption is that if it's not a big part of our atmosphere, how can carbon dioxide make that big of a difference? Okay, that's an assumption. Is that on a planetary scale, a little increase in carbon dioxide won't do much. Okay? Therefore, it's logical to believe that because carbon dioxide is not a big part of our atmosphere, what humans are putting out for carbon dioxide won't change the climate and global warming. I'm saying it because this is what scientists thought for a long time. Scientists thought for the longest time that if you're going to change climate, you have to put out so much carbon dioxide because the planet's huge. You have to change that percentage of carbon dioxide to be like 10, 20, 30% carbon dioxide if you want to get those kind of changes. Today we're talking about like 0.4% going to 0.5%. That's not a big change. Okay, and so scientists are like, well, who cares? 1% is not going to make a difference. Turns out with more data, more information, it does. And again, this is what a lot of scientists used to believe, and some are still continuing to believe with that. Another one, carbon dioxide occurs naturally, and it does. Okay? In small amount, it's very efficient at absorbing heat energy. Again, on a planetary scale, a little bit of carbon dioxide will make a huge difference in that heat absorption. Therefore, it's logical to believe that humans are causing climate change. Okay? And again, you can see how, with a slight change of words, we can have a totally different belief system in there. Okay? And again, we can change our beliefs as we experience new things and totally flip it. Okay? And so today we're going to be talking about that data. So the science is a way of knowing about the natural world and the processes within our world. But again, we need to make sure that we all understand that science is fluid. Science changes all the time. Okay? And that's the cool part about science, is that we're constantly doing science. It is not set in stone. Right? There are lots of things that are not set in stone with science. So with hypothesis and data collection and testing and communicating results, we can change the science, we can change what people think about it. So our activity for today is looking at climate changing. We're not going to focus so much on the human part today, this week. We just want to see, is it changing? Is there global warming? You've heard me say it multiple times that you can't really argue about this part. Can we argue about why or what to do with it? Sure, we can argue a little bit about that. So today, we're going to look at the evidence. Is climate changing? Okay. The very first thing that we all need to make sure we are good on, especially today in Kentucky, the difference between weather and climate. And trust me, people say this stuff all the time. They get these two words mixed up all the time. Weather is what is happening right now, this week, in the atmospheric condition. Okay? at a specific point in time. Climate is what is happening in long term. So you can't say things like, oh, it's cold today, I guess there's no global warming. And yes, people say that all the time. And it can't, that's weather, that's not climate. That's not global warming, that's weather. People say stuff like, well, we had snow in April, there's no global warming this year. Yes, we can have snow in April. That's weather, okay? That's not climate. Okay. So you got to be very, very careful about the use of words like weather or climate or saying things like that, okay? Even some of the most powerful people in the world get these words mixed up sometimes, okay? And so today we're going to be looking at long-term effects. We're not going to be looking at the temperature today where it's cold in Kentucky or hot in Kentucky or whatever, okay? We're not going to be looking at how much rain did Kentucky get this year. We're going to be looking at long sets of data, okay? All right, so again, climate change, just make sure we're aware of this as well, especially for Kentucky. It's not going to be the same everywhere. Okay, it's not going to be the same everywhere. Some places are going to get wetter, some places are going to get drier. Okay, some places are going to get more wind, some places are going to get less wind. Some places are going to see a bigger impact, some places are going to see a smaller impact. For example, Kentucky. Climate change is not really going to impact us all that much. Our winters are going to get milder, but we're not a winter state. We don't have polar bears running around Kentucky. Okay? Now, if you live in a ski mountain of Kentucky, and your mom and dad live in a ski resort, or for example, Perfect North, if you or your parents work at Perfect North in Indiana, that's going to have consequences. You're going to have a hard time keeping that artificial snow frozen, right? And that's your job. That's your parents' job, or whoever it is. Okay? But again, in Kentucky, we're a very mild state, probably going to stay that way. So things that we're going to look at, average temperature, not Kentucky temperature, not northern Kentucky temperature, but an average temperatures. We're going to be looking at precipitation, ice, snow, be looking at sea levels, and we also be looking at extreme weather events. With climate change, global warming is going to increase extreme weather events. And it's already happening, we know this. Every year in Kentucky, it seems like we get these really massive storms that blow down all the trees, that cause a bunch of flooding, tornadoes. Okay? It is happening more and more and more frequent. Even the snowstorms, we're getting dumped on by 10 inches of snow. That's not really typical. All right, so here's the first graph we're going to look at for today. I want you guys to group up. You kids at home are going to group up as well on home. So let's go back to today's worksheet, which is this one. You guys are going to answer a couple questions. And you kids at home are going to work together. But here's what I want these tables right here to the front. I want you guys just to spin the top of the table behind you. Okay, answer these questions. All these tables right here, I want you guys to spin the top of the table behind you guys. All right, let's take 5 minutes. 5 minutes, answer the first graph. Talk to each other, answer the first graph, 5 minutes. All right, kids at home, I'm going to put you guys into breakout groups. All right, kids at home, I want you guys to take 4.5 minutes and work on question number 1 only. Start my timer here. So yeah, we're just working on question number 1. and be ready to actually discuss and talk and argue about this stuff. All right. Guys, right here. You could join me. You guys are talk about it. You gotta work. So yeah, question number one. We will do question 2 and question 3. Don't worry. Question number 1 for right now. Make it good. If you complete sentences, complete ideas. Yeah, we're going to do draft number 1. We're going to do draft 2 together, draft 3 together. So just take a question for draft number 1, awesome, and anything. All right, take about 90 seconds. Finish up graph number 1, 90 seconds. All right, about 30 seconds. Be ready to discuss. Ready to discuss what you think about graph 1. I want to hear everything. I want to hear the argument for, against, all that good stuff. All right. Let's just kind of spin around a little bit. You're going to go right back to another group in a second, or back to that group in a second. But let's just turn and listen real quick. We'll do number 2 in just a second. All right. First off, before we discuss this too much, and again, I want to hear everything. I want to hear all the ideas. One thing that you're going to commonly see when you're talking about climate change, global warming graphs, and it's not always, but common, it's the start date of the graph. A lot of climate change information and data, you need to look at the x-axis. What is this graph talking about? This graph talking about millions of years, or 1 year, or decades? That's a big difference, right? Most of the climate change data graphs, especially when they are specific about certain things, they are going to go back about early or late 1800s, 1880s, 1890s. This is when the scientists were collecting this data. Okay? Before that, you go back to, 1600s or something, there wasn't really people taking this information. Now, that's not to say that we can't find an old newspaper from England in the 1300s that say today's weather was nice and warm and sunny, but most of the data is going to start in the late 1800s when scientists started actually collecting it. There's also another reason why we use that number, the late 1800s, especially around 1870s, 1880s. What happened in the world history in 1870s, 1880s?
The Industrial Revolution.
Jason, were you going to say that too? All right. So, the Industrial Revolution, the use of fossil fuels, coal, electricity, those types of things, they kind of start in the 1870s, and then by the early 1900s, 1901, 1910, you start getting actual real electricity and things like that running the cities. And then, of course, everything after that. So that's kind of what we're looking for at the Industrial Revolution. Did people use fossil fuels before that? Yes. But were we using it the way we are today? Absolutely not. So that is just something to kind of think about. All right, kids at home, I want to see stuff in the chat box. What does this graph tell you? What do you think about this graph? Graph number 1. You guys talk. I know what it tells me. You guys run a group. What did your group come? Question number 2. What happened? Anything? Crickets? Crickets? Trying to make this more interesting, more fun for you guys. All right, we got stuff up online. All right. Hannah says it's happening globally, not just one area. How do we know that? That's a good statement. How do we know that? All right, so we have stuff. We have stuff from all over the place, including even Japan, having some data in there with us. And note that they're very similar. They're, if not almost exactly the same. Okay? They're very, very similar with each other. So, what does the data tell you about the global average surface temperature? Yeah, it's increasing. Does this graph say anything about humans doing it? No, it just tells you temperature. Okay? So, graph number 1, it's just showing you the average temperature is going up. Now, tomorrow, could it start going back down? Sure, it could. It hasn't really been doing that for the last couple decades, but it could. Okay, so as a scientist, we need to make prediction of what we think will happen in the future. Do we think the graph is all of a sudden going to start doing this? I mean, it could. But as a logical human being, what do you think is more likely to happen? Probably follow a similar trend, right? Now, right here, that might not be that bad. But up here, that might be horrible. All right? So that's what we're worried about. We're worried about the grandkids. Right? But again, maybe it'll start coming back down. Maybe. Okay? It's just gotta look at the data. All right, let's look at number 2. When you guys, let's spend a little bit less time on this. Let's spend about 3.5 minutes on it. So question number 2. This is the surface temperature for the last 1,000 years. Not the last 100 years. The last 1,000 years. So, kids online, I'll just let you guys all talk together right here. Turn on your mics, talk to each other. We don't have to do a breakout group. Just work together. Question number 2. Question number 2, take about 1 more minute. Just listen for a double click. Just double click to the left. Yeah, that's not gonna. All right, graph number 2. What does this graph tell you? Again, I want to hear it all. Bring it, bring it. Let's talk about it. What questions do you have? What you like, what you not like about this graph? Landon says show fluctuation in climate where it began. You mean when? It's different between where and when. Yeah. All right. Now, has climate been changing for the last 1,000 years? Yeah, the line's going up and down every year. The line's going up and down every year for the last 1,000 years. Climate has been changing. Okay, it got really cold this decade or whatever it was. That's fine. Climate can change. But what is worrying some to you? That part, right? That part is worrisome. And again, you look at the years, you're talking late 1800s, you're talking 1900s to today. And again, what happened there to start that? Right? It can't just be a coincidence, right? And so, again, can climate change naturally? Of course. How do we get data from 1,000 years ago? Well, we have historical records like newspapers, I just said. But we also have tree rings, we have coral, we have ice cores. We're going to talk all about this stuff later, okay? But we do have data going back. We'll talk about it, okay? But again, the biggest changes are going to be these big gaps, these drops. Those are big changes in climate. What do you think caused big gaps to go down like that? What kind of thing that are not human, what kind of thing could drop the temperature down all of a sudden? Can anyone think of that? Eh?
Volcanic eruption.
Okay. So now, do we know? Maybe, maybe not. But there are things that can cause the climate to go back down. But look, it goes right back up after a couple of years. Okay? So yes, things can happen to cause temperature to go down and up. So for us humans, maybe we want to have a bunch of volcanic eruptions, start bringing that data down. Okay? Hey, Stevie. All right, let's go ahead and spend the next 4 minutes, and let's try to go ahead and get all three of these graphs done together in the next 4 minutes. Talk to each other, help each other out. I think there's 3 left. 1, 2, 3. Yep, on that. I don't know why I said, oh, okay, 1B. Yeah. That should be graph 3. All right, so again, spin, talk to your group, help each other out. Let's try to get these 5 graphs done today. Take about 90 more seconds, try to get to the last couple graphs done. Worst case scenario, you have 10 minutes of homework tonight, or you can work on it tomorrow. code, you're gonna need activation code for
Oh,
that.
I know, I clicked the link from my email. It's not very good.
One first. I mean, open it. All right, so tomorrow, we're gonna spend a couple minutes just talking about graph 3, 4, and 5 on there. Now again, worst case scenario, 10 minutes of homework tonight, work on it tomorrow, type of thing, not a big deal. But try to get these done together, help each other out. Yes. All right, last thing before you leave. Yeah, you might want to read my message to you about the YOP data representation. There were some graphing issues on that. I just need to see your graph. However you want to send it to me, just send me your graph for fixing. I can fix that. Not a big deal. All right, that's it for me. Have a great day. I'll see you guys tomorrow. Have a good one, guys.